Okay, let's welcome our next set of speakers for the sign extender. Yeah.
I'm not touching the computer. You touch the computer.
Am I doing the first?
I break it.
Am I going first?
I don't know who's going first. Am I going first?
Yeah. I thought I was doing the slide, the first and second.
Go for it.
Okay.
I don't have the energy for that.
I mean, do whatever makes you happy.
All right, we're doing the sign extender.
Nice.
So what is it? It's the process of increasing the number of bits to 64 bits. If the first value is 0, which means it's positive, we're going to keep it 0, so the number is positive.
How many bits was it to begin with?
I mean, probably 15.
What was the question?
16.
If we go to 64, how many bits was it to begin with?
What?
Oh no.
A number between one and another number.
That was a great answer.
I know, I have a lot of them. And if the first value is 1, it keeps them all 1 so that it stays in negative. Why we need it, memory does not always give out a 64-bit integer. And we add or subtract 2 integers when they could possibly have a different number of bits. There you go.
Me?
Yeah.
Me? Okay.
It's good that you're blocking the screen.
What feeds into the sign? So the instruction memory feeds into the sign, and then it outputs to a mux and an adder.
What part of the instruction memory?
Oh my gosh.
Just throwing us under the bus.
I know. Hit the button again.
Oh, nice.
Mhm.
Nice.
Mhm.
So what part is that?
I can't read that. You can see that.
It's the part that's connected right there.
Yeah.
No.
All right, just keep going.
Okay. Instructions used: the JALR jump and link register, CMP compare, is that move?
Yep.
Okay, move, and CMove or CMOV conditional move, the add and JA or jump above. Is that me? This is you.
Yeah. All right, some more information about this. It is a structural flow, mainly because it is a structure that you will need to implement rather than data flow. The gate delay should be changed. So since nothing happens instantly, it needs to be at least 1, but because it's just adding integers in front of a 16-bit number to make it 64, it happens pretty fast, but you need at least to have 1 gate delay in your test files and stuff like that, or when you're implementing it. So, but when you're testing, you need to put in 1 since nothing happens instantly. And then,
Oh yeah, that's hard to read. We'll do that.
All right. So the test cases, basically, there are 4 test cases. One where the number was negative and it put 1s in front of all of the numbers. One where it was positive, it put the 0s in front of everything. And the 2 cases where it was too many bits or not enough bits. So that's the thing. And problems we encountered was the modules were misnamed, and when we entered a larger bit number, it issued a warning, but it still run correctly, and it also, missing commas, semicolons, all that fun stuff.
That's it.
So any questions,
any questions about the sign extender?
before your professor goes all out?
Oh my gosh.
Please.
I mean, it won't be that bad. Come on, guys.
We'll
We
see.
need to go to work.
So everyone has it? Perfect.
All right.
Nice.
Well, now,
Hit us up.
let's go back to your instructions that you've listed that were needed. Actually, yeah, let's go there. All right. So jump and link we didn't talk about in class yet, but that's okay. Why do you think we need to use compare, or when will we use? What part of compare requires this?
Part compare.
You listed as instructions using it is a compare.
Mm-hmm.
Where does compare use it?
Where does compare use this?
Yeah.
I mean, probably because one number could be 16 bits and another one could be.
Well, go back.
All right.
So there's your architecture diagram.
Yes.
Compare is comparing the two outputs from the register file.
All right.
Mm-hmm.
So I don't think compare actually uses the sign extent.
Oh. Whoops.
That's all.
Okay.
But
Well.
one thing I hinted in class is that my diagram is actually not complete. You have the sign extent in one of the spots. Where's the other spot it would need to go?
Let me see.
Go for it.
I can't see it. Wow, it's so tiny on here.
Well, you can go look at the projector instead. You
I
can
can't
pull it
like
up.
that. The words. I see it there.
I think I
Remember?
mentioned it.
I feel like
Can't
we did
remember.
mention it.
I know we looked at the slides for all this, so.
You did the slides?
No,
No,
we
no,
looked
no.
at
We
your
looked at the
slides.
slides as a reference.
Yeah, yeah, yeah.
We made your slides.
You just copy and pasted from mine?
Oh,
No.
we made
Only the
yours.
picture.
Did you cite me?
No.
Plagiarism.
Pictures by Dr. West. Cited.
There we go.
Excited. There we go. Did we already say that? I feel like.
Well,
Can I look at the other slides?
So, okay, hold on. How many bits come out of the data memory?
Where's the data?
It's on the
I'm gonna
right.
say 64. No, it's not.
So this is the trick, is the data memory only gives you 32 bits.
Oh.
Oh,
Oh.
oh.
So it needs to be after there.
Yes.
Okay.
Now here's the other problem. The sign extended on top, how many bits are going into that one?
16?
16?
Yes, how many would be going into the one after data memory?
32.
So how many sign extenders do you need?
Two.
Two. All right. Good
Math.
job. All right.
Any
let's-
more
Any
questions?
more questions? Let's see. Yeah, that's good.
All right.
Nice.
Thank you for your time.
You should have had the music playing.